Okay, here we are with a question about the force of attraction or repulsion due to two parallel wires, X and Y, carrying the same current. As usual, hit pause, try the question, and then when you are ready to see an explanation, please press play. Okay, so we know initially that there is a repulsive force. That's important because later we're going to have to determine if a new force is repulsive or not. And we know that that is F on each wire. The direction of the current is in each wire is also reversed. Okay, and the current is doubled, and the current in X is doubled, and the current in Y stays the same. We also double the separation. So for this, we are going to use our equation F over L equal to mu naught Ix Iy over 2 pi r. And we're just going to see what happens when we change those numbers. And we're actually going to try and answer this question kind of all together. All right, we're going to try and look at what happens when Ix becomes minus 2x, Iy becomes minus y. Now here I'm kind of treating our current as a vector. Those of you in my lessons will know that current can be treated as a vector at times because it has direction. And r is becoming 2r. So we're simply just going to calculate the new version, inputting these two ideas. So we've got mu naught times minus, we've got 2 pi 2r, and you'll notice here that we've got the cancellation of that factor 2, and also our minus signs cancelling as well. Okay. Now what that means is that F dash over L is equal to F over L. In other words, the magnitude is the same, and the direction hasn't changed either. That is because we've taken a positive number and turned it back into a positive number. In other words, the change in the field direction due to this minus Ix, for example, combined with the change in the current direction, cancel each other out to produce exactly the same force that we had in the first place. A really good question, test your understanding there of direction and magnitude of magnetic fields.